Hey guys, I am here to work out the odds to the Chapter 2 review for Geometry AB. We're going to start with problem number 1. The original conditional statement is if an angle has a measure of 60 degrees, then it is an acute angle. So what I'm going to do is I'm going to highlight my hypothesis and highlight my conclusion a separate color. I will call this my hypothesis and my conclusion. And what you want to do for the converse, remember you want to flip it. So we still have if and then in our sentence, but instead of putting the hypothesis first, we're going to put the conclusion. So if it is an acute angle, then now I'm going to put the hypothesis at the end because I'm flipping it. Then it has a measure of 60 degrees. Okay. Now for inverse, we start back at the conditional. Inverse, you want to do the opposite. So the opposite means to negate, so we're going to negate it. So if it's raining outside, the negation of that would be it is not raining outside. So I want to keep the same order as the original, but instead of writing an angle has a measure of 60 degrees, I want to negate that and say if an angle doesn't have a measure of 60 degrees. Then, now I want to negate the other side. It is an acute angle. The opposite of that is it is not an acute angle. And I'm just using the angle symbol there. Contrapositive. Contrapositive flips and does the opposite meaning. So we're going to talk about the conclusion portion first. If, and we want the opposite meaning, if it is not an acute angle, then opposite of the hypotenuse, it doesn't have a measure of 60 degrees. And we'll go back and decide the truth values. If an angle has a measure of 60 degrees, then it is acute. That is true. 60 degrees means acute. The converse, if it's an acute angle, doesn't necessarily mean it's 60 degrees because it could be 59 or 20 degrees and still be acute. So this is going to be false. Inverse, if an angle doesn't have a measure of 60 degrees, sorry, that kind of looks like the sentence. If it doesn't have a measure of 60 degrees, then it is not acute. That's also false because you could still be 20 degrees and still be considered an acute angle. And then the contrapositive is if it is not an acute angle, then it doesn't have a measure of 60 degrees. That is true. Not an acute means it definitely is not going to be 60 degrees. All right, let's skip down to number 3. Number 3, write a counterexample for each statement. If an angle is obtuse, then its measure is 120. When you do a counterexample, you really want to make sure it's something that proves your statement false. What makes it false is the second part has to be different than what they said. So I still want the hypothesis true. I still want to talk about an obtuse angle, but I want something that's an obtuse angle that doesn't measure 120. So I'm thinking, okay, what if I have this obtuse angle that's 110 degrees? It's still obtuse, but it's not 120, so that's a great counterexample for that. All right, let's flip to the next page, page 2, and look at number 5. Number 5 wants us to write the statement in an if-then conditional statement. And we want to underline the hypothesis once and the conclusion twice. So a triangle has 3 sides. I want to figure out what the hypothesis is. And essentially, I'm just going to kind of draw a line at the break in this sentence and use the beginning, a triangle, as my hypothesis, and the end, 3 sides, as my conclusion. So if I put this in if-then, I could say if a shape is a triangle, then I can say it has 3 sides. Sometimes you have to add those filler words so that it makes sense as a sentence overall. So if we underline the hypothesis, hypothesis always comes after the if. So I'm going to underline that once, a shape is a triangle, and then underline it has 3 sides twice, which is the conclusion because it comes after then. Number 7, write a biconditional for the given statements. If a triangle has 90-degree angle, then it is a right triangle. If a triangle is a right triangle, then it has a 90-degree angle. That's supposed to say angle. These sentences are basically saying the same thing. One is just the conditional and one is the converse, the flipped version of that. So what we're going to do is, let's just say we take sentence number 1 and identify the hypothesis. We'll call the hypothesis a triangle has a 90-degree angle. And we'll call the conclusion it is a right triangle because it comes after then. So what you're going to do, the format for biconditional is hypothesis, if and only if, conclusion. So you're going to drop the if-then format and now put it in hypothesis, if and only if, conclusion. So I'm going to write my hypothesis. A triangle has a 90-degree angle, and then put the format if and only if, and then write my conclusion. It is a right triangle. Trying to zoom out, but it won't let me. Oh, there we go. Okay. So now we'll skip to number 9. Number 9 is right here. And number 9 wants us to write a counterexample for the following statement. Any four-sided polygon is a square. So again, with a counterexample, you still want the beginning to be what you're talking about, and you still want a four-sided polygon, but we want something to prove it false. So I want a four-sided polygon that is not a square. So other four-sided shapes that are not squares, you could have a rectangle. That would be a great counterexample. Or another four-sided polygon is a trapezoid. A trapezoid has 4 sides, but it's still not a square. So either one of those is a good example of, or a good counterexample for that statement. Number 11, list the next 2 terms in the pattern. When you talk about a pattern, you want to see, okay, did I add between those numbers? Did I subtract? Did I multiply? Did I divide? You want to see how they changed. Well, 113 to 224 to me looks like it's adding 111. So 113 plus 111, and I'm just going to check this. 113 plus 111 gives me 224. So if I add another 111 to that, it should give me the next term, which is 335, which it does. And I'm going to just double check if I add another 111 to see if it gives me 446, and it does. So my pattern is adding 111 each time. The next term would be 446 plus 111, which is 557. So I added 111 there. And then I want another term, because we want the next 2 terms, so I'm going to add another 111. And that gives me 668. Make sure you'll read the directions to determine if we want the next term or the next 2 terms. Number 13, all of those numbers, when I look at them pretty quickly, I notice they're all divisible by 5. So maybe we're multiplying by 5 or we're adding by 5. So I'm just guessing and checking. 5 to 10, I could have added 5. 10 to 15, I could have added 5. 15 to 20, I added 5. And if you notice, all of that is the same. So that must be the pattern, that I'm adding 5 each time. So my next term would be adding 5 to 20, which gives me 25. And then the next one would be adding another 5, which is going to be that 30. All right, looking at the third page, page 3, number 15. Number 15 is the sequence 3, -9, 27, -81. The very, very first thing I notice is it goes from positive to negative to positive to negative. So that must mean I'm multiplying by a negative number. But I don't know what number, because a positive 3 times a negative number gives me negative. A negative times another negative is going to give me a positive. That's what allows me to alternate between symbols. So something that I could multiply 3 by to get to 9 would be 3. Let's see if multiplying by a -3 works here. -9 times -3 is a positive 27. And then try it again. 27 times a -3 gives me a -81. So I'm going to do one more time, -81, and I'm going to multiply that by -3. That gives me 243. And again, since we want the next two numbers, I'm going to multiply by another -3. And that gives me a -729. So those are your two answers for that one. All right, looking at 17, we have a series of figures. And we have, let's see, we have 2 blocks on top of each other, and then we have 2 blocks adding one to the side, and then we have the L, and then we're adding one on top, and then we're adding one to the bottom. It looks like we're adding another column of boxes each time. So we started with one column, then we start the next column, then we complete the next column, then we start the third column. So the next figure, which is what these directions want us to do, find the next figure, should be a completion of this one. So right now we have a cube with four boxes, and then we have the one that they just drew, and I'm going to complete that on top. So we've got 3 boxes on top and bottom, and it looks like what they were shading was everything except for your new box. So here we'll shade everything except for the new box, which was added at the top right. So that'll all be shaded. Okay, the next one, number 19 through 26, and you guys, there's not really a 26 blank, so you might want to add one. It looks like they should be lining up like this. So 19 is that one, 20 is this one, 21 is here, 22, 23, 24, 25, and 26. They were kind of off, so you might want to make sure you fix that. Number 19 looks at the figure right here, and you need to determine what things are going to be true or false. So looking at number 19, it says points A, B, D, and J are coplanar. Coplanar means together on the same plane. So when I look at A, B, D, and J, D and J are very obvious to me that they're on K, which is right here. And A and B look like they're where my two planes intersect. It's like I'm looking at an X, and here's the line where they're intersecting. Okay, so A and B are on this line, and it's going along the X of my planes. It's like if you took 2 pieces of paper and crossed them like this. You can kind of see where they're going to be. So A, B, D, and J are definitely coplanar. That's true because they all touch K. Number 21, points E, G, and A. E, G, and A are collinear. Collinear means on the same line. And so things we look for are, do we actually see a line going through those points, which in this case, E, G, and A, we don't see a line. And not only that, but the line doesn't have to be drawn. If it wasn't drawn, they would still look like they're in a line, which if I was to trace over E, G, and A, they're in different planes. It makes me form a bent line, so that would mean that one's false. Number 23, angle ABD is this angle right here, and angle EBC are this angle right here. Says those are vertical angles. Well, if I look at the lines that's intersecting, when I describe the location of those angles, they're opposite of each other. Opposite angles are vertical angles, so I would say that's true. 25, line FG and DE intersect. This one's a little tricky. If you notice, there's no point where they actually intersect. And I'll zoom in here a little bit so you can see better. And what I'm looking at is that here is a line going through K, and if you look, they go through B and C, but it's almost like they're separated. So like if you're on top of them, looks like you may be crossing like this, but if you turn it to the other direction, they're not actually intersecting. They just look like they were from one side. They're almost behind each other. So this is going to be a false because they don't intersect. All right, I'm going to stop this video and then I will catch up for the next pages, page 4 and 5 on the next video.